All right, welcome. My name's Jeff Olchovy, and I'd like to talk about what I believe is the most underappreciated and perhaps the most misrepresented tool in the Scala Developers Toolkit, SBT. I hope most of you are somewhat familiar with, or at least are aware of the de facto build tool in our community. It provides us with all the common features you'd expect from a JVM build tool and more. You get incremental compilation, dependency management, an interactive shell, continuous compilation, testing, and deployment. But with that being said, I'm not here today to give you an introduction to SBT and its features, nor am I here to provide a tutorial on its fundamental concepts, or to go deep into its internals for that matter. Rather, I'd like to spend some time explaining how and why SBT became so much more than a build tool at TapAdd, and how it has become foundational to our developers, moreover, our entire engineering organization's productivity. I guess a little exposition is in order here. I'll try not to digress too far from the main topic. TapAdd, an ad tech company founded in New York City in 2010, acquired by Norwegian telecom Telenor in 2016, has exclusively authored its back-end software systems using Scala since its inception. We have over 60 active Scala repositories, all of which use SBT as their build tool, coupled with a choice selection of community and in-house developed plugins. We've contributed back upstream to 4 of the more popular and widely used plugins, and we've developed about 13 of our own. 5 of these are now open sourced and made available to the larger community via the typical distribution channel, so you can get them on Central or the SBT Plugin Releases Getrate repo. If you're interested in learning more about our story, how we use Scala, our growing pains, successes and failures, please attend our CTO Doug Leoden's talk, Building a Company on Scala, today, right after this talk, but up in Auditorium 11. So it's no understatement that SBT is a core critical component of TapAdd's tech stack. Its use, beyond that of a build tool, has largely been responsible for delivering the massive efficiency gains that our engineering organization has come to appreciate, or take for granted, for that matter. SBT and its interactive shell comprise the interface to our standardized application testing, release, and deployment platform. Artifacts and applications are delivered, updated, and scaled across 4 global data centers against various execution environments. So whether the need is to spin up an additional 10 instances of a long-running app on one of our Mesos clusters, or to schedule an ETL pipeline globally across all of our Yarn clusters, our developers and data scientists leverage SBT to do it all. And to them, it's as simple as invoking clean compile test. Now, even if I can take all of our trials and tribulations, all of our learnings, all of our hard-won knowledge with SBT, and I can package it up into a pill for you, you may find it still just too hard to swallow. And that's okay. My goal here is different. By the end of this talk, my hope for you is that those of you who are not currently using SBT consider or reconsider adopting it as your build tool for Scala development. Secondly, for those of you who are just getting by or are simply coasting along with SBT, I encourage you to really dive in and begin exploring the space. I'd like you to ask yourself the following questions. Am I fully leveraging SBT's potential for my project's build, release, and deployment phases? During the iterative development of my project, how many times am I invoking a process, some bash or Python or Perl script, some glue code outside of SBT? Is it to generate some source, transport an archive, spin up a container? I mean, SBT and its plugins already do all of these things, so why not for you? Lastly, for those of you that already grok SBT, you're experts. My ask for you is that you consider giving back. And giving back doesn't necessarily mean giving back in terms of technical contributions, though I'm sure that would be welcome, so don't hesitate before taking out your pull requests or open sourcing your plugins. What I'm really getting at is if you feel strong enough, or if you feel righteous enough, consider making an endorsement for SBT. Hate and FUD spread quickly on the internet these days, so in the next Hacker News or Reddit thread where the flames are being fanned, why not shine a little light on some of the darkness? Saying something like, I use SBT, our team uses it, I wouldn't consider using anything else for Scala development, would go a long way into informing the decisions of our larger community and also its mentality. But enough of that. Candidly speaking, TapAdd's and my personal journey with SBT wasn't without its hindrances. After some reflection, I like to think that the journey can be broken down into about 3 discrete phases. For the first 2 or so years, you could say we were just getting by. Every project at TapAdd did in fact use SBT, but at this point in the life of our organization, projects were few and far between. We had only a couple of repositories, and we had little need to break apart our monoliths. Complexity was on the rise, though, and it was manifesting itself in our build definitions. We tolerated SBT, harbored no great love for it, but that all changed once we really bit the bullet and proactively decided to embrace SBT. Now, as much as I appreciate engineers that push the boundaries of software development, I firmly believe that if we find ourselves wrestling with the technologies and tools that we use on a daily basis, the tools that are supposed to make our lives easier, it's a sign that something is very, very wrong. Now, I honestly can't say why developers are having such a difficult time with SBT. You guys are working on so many more complex problems. But I'm biased, and I know that SBT has taken some considerable strides forward since the 0.7 days. Simple build tool it was not. Simple build tool it still may become. But what I believe I see happening is that developers are not evaluating SBT based on its current offering. They're evaluating it based on a perception that is both stale and outdated. And I get it, first impressions are very hard to overcome. I'm sure there's a name for this phenomenon, but it reminds me of when a parent fails to envision its son or daughter as anything but a young child. And while this difference in perception may seem harmless, I actually think it's quite unfair and potentially damaging. Just as we evolve as developers, as craftspersons, as humans, so do our tools and our technologies. And I believe it's especially important that when we evaluate or reevaluate the components of our tech stacks, we rid ourselves of any preconceived notions, any outdated hearsay, any biased nostalgia, and we evaluate these components based on what they've become, not what they were. Although SBT has made considerable strides forward in simplification, deprecating the extraneous symbolic operators, auto-importing of plugin settings, getting rid of the build trait, introducing the multi-project build.sbt file and the .value DSL, I find the learning curve still to be rather steep. And to use a better word, maybe rather staggered. I liken the learning curve more to a matter phase change chart than something that can be described by a simple mathematical function. And steep learning curves are not necessarily bad, especially those with a steep start. You can argue that they actually represent the idea that one can make rather rapid progress relatively early on. From my point of view, SBT's learning curve does allow for this rapid type of progress, but it also provides ample time to coast without making any gains at all. So given a greenfield project, and whether you start from a blank slate or copy and paste an existing build definition, it doesn't take much to figure out how to configure your resolvers, add library dependencies, choose your testing framework, and clean compile test. The harm comes in these next coasting phases, and I get it. The amount of energy and time that one took to climb, the amount of energy and time that's going to take to reach that next plateau is not insignificant. But the value received in those next phases of learning is very much worth the investment. So I want to circle back to the main point here. And in hindsight, it's what I feel could have really fast-tracked our journey with SBT, and that is to fully embrace it. Try to cut those coasting periods short. Try to summon the internal motivation necessary to climb over those slopes. The concepts, relatively speaking, are not that difficult to understand. And since your intuition may not prove as useful as you'd like, there's plenty of resources to help you along, including a swath of rather comprehensive documentation. Now, I know for certain, sitting down and tearing through volumes of technical docs is not the favorite pastime of many developers. I think we see it more so as a necessary evil. But when the time comes, it's always nice to see a tool or technology provide unbounded, comprehensive, readable documentation for its users. You may disagree that SBT provides this, but I think the most complaints I hear about SBT's documentation is not that it's lacking, or that it's missing, or that it's hard to find. They're complaints of a different nature, and I feel that's going to be addressed in the near to immediate future, so stay tuned on that. But on the whole, I do think developers are either giving up too quickly when they hit a wall, or they just aren't starting from the right place. For those of you who haven't even taken a tour of SBT's docs, or a recent tour of SBT's docs, I think that's where you've made your first big mistake. The message is rather clear, isn't it? You will save yourself a lot, emphasis there, of time if you have the right understanding of the big picture up front. And to reiterate, there are not that many concepts, but SBT is not exactly like other build systems, and there are details you will, again, emphasis there, stumble on if you haven't read the documentation. So please, users old and new, invest the time to revisit or to finally read the Getting Started guide. The estimating reading time, based on a conservative, 200 words per minute, is only 54 minutes and 45 seconds. 11,000 words. An hour of time, less than an hour of time, to take you from novice to intermediate, to get you over your first hurdles. That first or second slope that I showed, is it worth it? You'll have to decide for yourselves, but I really, really urge you all to reread the Getting Started guide. Now, beyond SBT's documentation, what I find extremely valuable is its active and responsive community. With GitHub nowadays, quite easy to put your fingers on its pulse. You spend a little time in and outside of its repositories, the mailing list, the Gitter channel, you'll inevitably run into Eugene and Dale's aliases and avatars. I don't want to leave any core contributors out, Mark, Josh, and the rest of the folks that did a lot of the heavy lifting in the past. They've done great. But these two guys are everywhere at once. I'd also like to recognize Jorge at the Scala Center has been doing some amazing work on improving SBT in Zinc. If you post a question on the Gitter channel, there's a 90% chance one of those three will point you in the right direction within minutes or hours of your post. So aside from putting a lot of care and time and effort into core development, it's very promising to know that SBT's maintainers, contributors, the folks from the Scala Center, they're readily available and willing to engage with the community on the issue that matters most to the users. Now, I can't stress how important community is. I don't think Maven or Gradle has anywhere near this level of active participation. Sure, plenty of people use it. But if you have any questions, complaints, commentary, please do not hesitate to reach out to SBT's contributors. Beyond the custodians, the community is largely shaped by a healthy, diverse, and constantly improving plugin ecosystem. As an aside, I find it hard to believe that for all the complaints I see developers making about SBT, SBT's docs, its internals, the amount of community plugins, and the quality of them for that matter, continues to increase. So something doesn't add up for me. But regardless, it's this ecosystem and the Scala-based plugin architecture that initially inspired us to really dive deeper into SBT's internals, which allowed us the knowledge to configure plugins and our build definitions to our heart's content. And eventually we began authoring plugins of our own. So I want to mention a few of the community plugins that have provided immense value to TapAdd over the years. Regardless if they are still under active development or if they follow the now advertised best practices, we feel that they are best in class in terms of value that they provide. And like I already mentioned, a few of these plugins really inspired us to get our hands dirty to start leveraging SBT. So without further ado, the following is our most valuable plugin dossier, or bestiary, if you will. These are the plugins that we can't help but to include from project to project at TapAdd. SBT Dependency Graph is perhaps the first plugin that I would voluntarily add to my global plugins list. It's an invaluable addition to any developer's arsenal for tracking down dependency and class path issues, especially when working with these high-gravity software stacks. These black hole dependencies that seem to suck in everything under the sun, including opinionated logging frameworks, the entire commons of Apache, and everything else that more or less should have been marked as provided. So aside from the pretty ASCII and GraphViz-like renderings, you get the handy reverse dependency by module lookup task, what depends on. So say I'm developing some library, and I need to clean up my class path a bit. Let's say log4j somehow got on there, have no idea what's bringing it in. With the dependency graph plugin, we simply ask, what in my application depends on log4j 1217? And we see it's the Hadoop client. Not really a surprise. And maybe we'll just go ahead and mark that as provided, especially if this is going to be included for use in a MapReduce, Spark, or Yarn application. Now, when the need arises to package our applications as fat jars, we at TapAdd make exclusive use of SBT assembly. And honestly, it's its bread and butter. You can't get any more direct than the single responsibility goal found at the top of its README. The goal is simple: create a fat jar of your project with all of its dependencies. That directness is something that I personally value as a programmer. What's more, and I'll touch upon this later, is the snippet pulled from the requirements section: the burning desire to have a simple deploy procedure. This is what we're striving for when we extend our build definitions with additional functionality. We'd like to receive a significant value add with limited complexity. However, not all projects, and by consequence, not all build definitions are simple. SBT assembly provides one of the best usage docs around for dealing with and using its features to sort out pathological class path and build issues. Everything from excluding an explicitly set main class, to discarding or concatenating resources, to excluding specific transitive dependencies is covered in depth. SBT assembly also has a special place in our hearts at TapAdd because it houses our first upstream contribution back to the SBT plugin ecosystem. In fact, it also inspired us to write our first plugin, SBT Jar Jar, back in the 0.12 days before shading support was offered as a built-in feature of assembly. Now, following in suit and sharing many of the same core principles is SBT Release. SBT Release, by far and away, is the best-in-class choice for encapsulating and customizing your project's release process. It provides the release command, which by default is going to give you what you want about 90% of the time. It will infer and prompt you for your release version, run your tests, commit a change set with that version bump, create a tag, publish your artifacts, yada, 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 publish everything upstream. Now, this process is entirely customizable. All it requires you to do is compose a release pipeline of SBT state transformations. Does that sound simple or complicated? In reality, it's much more simple than how it's described in the documentation. The convenience functions provided by SBT Release are usually more than you'll ever need to use. There's a good chance that you'll be able to describe what you want to do for your project's release process using existing SBT tasks and commands. So instead of defining your custom release procedure using some sort of custom state transformation like that, we simply use the provided functions to do things like run our integration tests, run our scripted tests if we're authoring plugins, invoke any arbitrary command that you can feed the REPL. Or we can script ourselves a custom deploy procedure by invoking a series of sequential commands. SBT Release and its sequential release process for us was the jumping off point for leveraging SBT as more than just a build tool. Let's move on to SBT Docker. This one seemingly propagated across our code repositories overnight. While SBT Native Packager, which is an awesome plugin in its own right, provides users with similar utilities, author and publish Docker images, for what I consider to be more traditional JVM applications, the potential for customization that SBT Docker offers is sort of second to none. They have both a mutable and immutable fluent interface for constructing your Docker file. They offer a wealth of example projects. It's safe to say that SBT Docker is the plugin I endorse for SBT users who need to build and push Docker images for their JVM apps. Now, for those of you unfamiliar, Twirl is Play Framework's built-in templating solution. And ironically, one of the only places we don't use Twirl, or SBT Twirl for that matter, is in our Play Framework applications. I don't say that to take a jab at Play, but I say that to complement the construction of the SBT Twirl plugin, which is super easy and convenient to use outside of Play apps. And this was the one non-negotiable we had when looking for a templating solution. Here we're using it to build Uzi applications, if you can't tell. Uzi application is a program written in XML, control flow and all. It's pretty awful, but Twirl makes it nice. So it's quick work to configure your source and target directories, hook into the existing clean and compile tasks, and start generating yourself some source code. Now, the next batch of plugins we use primarily when we're authoring plugins of our own. And this relates more to an architectural pattern we've grown accustomed to using rather than pure necessity. So given an SBT plugin that provides some additional functionality, let's say it allows you to communicate with an external service or system, we find that it's good practice to decouple the actual SBT plugin, right, the SBT wiring, from the more generic service or library abstraction. So for a contrived use case, you can imagine a multi-project SBT build where one sub-project is the actual SBT plugin, the other is a library. The library could be used outside of the plugin if necessary, of course, but as sometimes desired, one of the plugin's main responsibilities could be to include that library as a library dependency on a given project. So we utilize SBT build info for injecting contextual build information, in this case, the version of the plugin that you're using, and by consequence, the version of the library that you will include into the build. Now, given the same architecture, when we're thinking about release and distribution, it's necessary to cross-build our library artifacts for whatever versions of Scala we're using or we think our clients will use, while our plugin should only be built against SBT 0.13 and Scala 2.10. Now, I know this is going to change for SBT 1.0, and maybe if we have time, I'll talk a little bit about that later. But to keep this release process push button and simple, right, we want a single command invocation release from the project root, from the aggregate project, to do everything for us. We take advantage of SBT Doge. I actually am not sure if I'm pronouncing that right. I've never heard it pronounced. I've only seen it in writing. So SBT Doge allows us to do partial cross-building so that when we use the cross-build operator from our aggregate project, the cross-Scala versions we declare on those sub-projects will be respected. SBT Doge offers up some cute memetic syntax, so clean, such test, very publish, but we prefer just enabling the cross-per-project plugin on the aggregate and using the more banal cross-clean, cross-test, cross-publish, or plus-clean, plus-test, plus-publish, however you read that. So after wholeheartedly embracing SBT and leaning heavily on the community's plugins, the next step in our collective journey was something that I've already alluded to. And it's at this point where we really had to roll up our sleeves and get our hands dirty. And that's making SBT work for you. Now, I understand that this may seem to run counter to the don't fight it point posited earlier. But this is not so much about fighting as it is about persistence. Perhaps the best feature of SBT is that it allows you to write your build definition and the components to support your build process using Scala. Anything that you wish to accomplish is possible. And moreover, you get to do it in a language that you feel comfortable in. Because you're here now at Scala Days, it may even be the language you use before any other. If you can't accomplish exactly what you want, whether it's because of some lack of knowledge or some ignorance or even some limitation of SBT, don't give up. Revisit the docs, extend its surface with a plugin, ask for help. If you're mired in some build complexity, try to clean it up. Your build is part of your product. Treat it like a first-class citizen and make it work for you. Duct tape and bubblegum rarely are acceptable solutions when it comes to professional-grade software development. As I mentioned, one way of making SBT work for you is by extending its surface with plugins. Many of the plugins I ran through just before served as inspiration for us when we first set out to improve and tune our build processes. A few years ago, that's exactly what we aimed to accomplish. So I had mentioned SBT Jar Jar already, but the others that have been developed since then really were part of our initiative to leverage SBT beyond that of a build tool, and more so as an application release, testing, and deployment platform. SBT Docker Compose, our most publicly adopted plugin, developed by our team member Kurt, who unfortunately couldn't be with us here in Copenhagen, allows our developers to spin up an entire topology of containers to test their applications alongside all of its dependencies. This is entirely orchestrated from SBT. You put a Docker Compose.yaml file alongside your build, issue SBT Docker Compose up, and you're cooking. This is the best way I've seen so far to perform end-to-end tests for your entire systems. Now, outside of the testing realm exist SBT Hadoop and SBT Uzi. SBT Hadoop provides our developers and data scientists with push-button delivery of artifacts to HDFS. This is super useful when authoring scalding, cascading, traditional MapReduce or Spark jobs that need to be packaged as binaries and made available on HDFS. Following that, SBT Uzi then allows for the upload, execution, and scheduling of our Uzi, or more generally, our Yarn applications, and that will reference those artifacts uploaded to HDFS. And again, all of this is from within an SBT session. If SBT Hadoop provides us with release, SBT Uzi provides us with deploy. Lastly, SBT Marathon provides us with similar functionality for our long-running processes. We're able to start, stop, restart, and scale out any of our applications and services that run on our Mesos clusters, all from within the SBT Interactive Console. These plugins integrate directly with our typical build, test, release, and deploy procedures. If you can invoke clean, compile, test, you have more than enough knowledge to use these plugins. There's nothing magical about them, and honestly, their footprints are tiny. Over time, as we've been refactoring, reworking, and open sourcing some of our plugins, we've noticed a considerable decrease in lines of code and the surface area of the plugins themselves. I'd go so far as to argue that plugin development actually has become quite easier and much, much more standardized than when we first started. And for those old or new to the game, the first step, unsurprisingly, should be the documentation. But aside from how, I think one of the more challenging questions when getting started with plugin development is what? What exactly should my plugin do? What are the bounds of my plugin? And I think a great place to start is actually something that I alluded to earlier. Are there any shell scripts, Python or Perl scripts, any glue code that exists in your projects that you invoke from outside of SBT? Or for some strange reason, if you're a masochist, you invoke them using the process API. Those are prime candidates for plugins. Maybe you're doing some code generation with the protobuf or Avro compiler, pushing a Docker image to your registry, uploading an artifact to S3. Now, for those use cases specifically, I'd say leverage prior art and use the battle-tested plugins that already exist, but not to discourage any hopeful authors out there. Taking your marginalized scripts, making them first-class citizens of your build process, moreover, your product is perhaps the best way to enter into plugin development. Now, a question you may ask, what do you gain by this? What do you gain by doing all of this? Your scripts probably worked, or at least they worked in happy case or happy path scenarios. So why port Python or shell scripts to Scala? Why leverage SBT? For this crowd, I'm sure I can leave the first part hang as a rhetorical question, but I'll bridge the gap here. The given is that you get to use your language of choice and the environment that comes with it. You have the JVM, standard library, all the libraries you would use during the typical development lifecycle available and at your disposal. Now, the next pro I would add to this list would be testing. As I hinted, your scripts probably worked, but I'd wager a guess and assume that you haven't really tested them with the same rigor, if at all, as you have your main source code. Now, I firmly believe that your build is part of your product, and I go so far as to argue that it's a mission-critical part of its overall existence. Should the custom software you write to support that process go without any testing? Why do we throw our best practices out the window when we add a shebang to the top of our files? Now, I'm not saying that as soon as you start writing or porting these supplemental scripts to Scala, that tests automatically appear for you. But I think the absence of these tests then becomes inexcusable. Since you're using the same language that you use for feature development, you most likely already have a good workflow for authoring and executing unit tests. Maybe you use Scala tests or specs too. It's the same when authoring SBT plugins. Moreover, and this is actually a favorable improvement over typical Scala feature development, when you're ready for integration or end-to-end testing, SBT provides the scripted framework for exactly this purpose. SBT uses it internally, and it's rather simple to set up and get going. Now, as a caveat, scripted is somewhat lacking in documentation, but the surface is not very large. The idea is that you create a series of example projects that test the functionality of your plugins. You add a small test file with shell-like syntax, usually it's just a couple lines. It tests your assumptions, your expectations. Now, most of the good plugins out there play along and include a few scripted tests. So as a helpful hint, if you find a plugin that is lacking in documentation, check out their source SBT test directory and see if they have any example projects that can teach you how to actually leverage the plugin as the author intends. Now, the other perk you get, clean distribution and delivery. No more haphazard proliferation of shell and Python scripts to some non-standard directory in all of your repositories. Once you adopt plugins, it's a simple addition of add SBT plugin to your plugins.sbt file, and you have your extended functionality. Granted, there are ways of leveraging another language's or framework's module system for this, but nearly every time I browse repositories and projects that have not embraced plugins, I always see some telltale scripts or bin directory that houses copy and pasted, out of sync, untested scripts, probably non-portable, and they're used for awfully important tasks. Now, small scripts and scripting languages have their place, no doubt, but reflect upon the ones that you're using. Have they increased in complexity at all? Have they been copied to multiple locations? Do you remember who was the original author even? If this is the case, consider recreating that type of functionality with plugins. Now, to close on plugin development, I want to quickly mention 2 additional resources that may prove valuable. I understand this talk comes across more so as an endorsement rather than as a technical deep dive. So those of you who are looking for more hard and fast tips when it comes to plugin development, this hopefully could be for you. I've recently published the blog post or tutorial version of an SBT workshop I gave at FlatMap Oslo this year. You can find it on Medium under the TapAdd engineering organization. Of particular interest to this audience may be how to author plugins that integrate with some external service or system, how best to leverage things like Getrate, the scripted testing framework, SBT Doge and SBT Release, which I talked about. Basically, how to make authorship and distribution as easy and as painless as possible. So if you're looking for and you think you would enjoy more of a technical walkthrough of complex plugin development, please check that out. It'll teach you how to build a SBT plugin that tweets. Secondly, Justin from JetBrains, who gave a talk on SBT fundamentals at Scala Days Chicago, he recently contributed a Getrate template to aid in the creation of SBT plugins. After a quick review of its source, it looks like you have all the necessary scaffolding to build, test, and publish your plugin back upstream for community use. So if you're thinking about authoring a plugin in the near future, definitely check out and use his Getrate template. It's under the SBT organization on GitHub. Since I've mentioned Getrate twice now, for those of you that are not currently using Getrate templates, I'll use that as my segue because, again, this is one place where we really make SBT work for us at TapAdd. At TapAdd, not everyone has a lot of know-how when it comes to SBT, but all of the engineering staff freely leverage and use it without any ill regard. They are good operators. One thing we realized, and this was rather later on, was that as our projects and our repositories increased in number, size, and scale, we saw a lot of variety in our build definitions, a lot of variety in the libraries and the plugins that were being included and the versions of them. Basically, the overall project structure varied from repository to repository. It was quite a mess. We had no standardized convention for creating new Scala projects, and that's what we set about to fix. See, typically, developers would copy and paste from an existing project, or start from an empty build definition and extract chunks of functionality from projects that they felt comfortable with, or worse, from the internet. And this leads to a massive amount of cargo culting and divergence from our ideals. So to counter this, we spent some time looking into templating solutions, including TypeSafe Activator and Getrate. We decided on investing some time into Getrate, and in short order, we were able to define a series of common templates that define our archetypical TapAdd Scala projects. Fortunately, we like to think we bet right, and as of 0.13.13, SBT supports the new command, which will evaluate a given Getrate template for you to generate a project. So whenever it's required to create a new repository, project, application, library, service, what have you, TapAdd engineers can utilize these templates to help scaffold a complete Scala project that adheres to all of our conventions. Once we adopted Getrate, it was quick and rather fun work, to be honest, to create a series of application archetypes for our entire organization. Now, all of these are configured with our preferred project and build structure, our testing conventions, the select plugins I mentioned earlier, and everything here is able to be released and deployed to either our Mesos or our Yarn clusters, all from within SBT. It's really a push-button instant gratification workflow that saves our developers and data scientists a bunch of time, and it really preserves our core TapAdd ideologies across teams. Now, none of these things are truly difficult to accomplish by themselves. We're not doing brain surgery or rocket science here, but utilizing templates like these removes a lot of overhead for our engineering staff. And I think the benefits of imposing a bit of structure on SBT projects are rather obvious. I would much prefer if my developers spent 2 days on feature development rather than figuring out the ideal class path for running a Spark job on our Yarn cluster. For an inexperienced developer, fiddling with the build may be a very, very expensive rabbit hole. Now for us, the use cases of Getrate templates go on and on. I'll list the rest visually here to serve more so as inspiration rather than instruction. We have application archetypes for Kafka producers and consumers, HTTP and ThriftSmux servers, templates to help developers create and publish both internal and open source libraries. We even provide a template for engineers that would like to create their own application archetypes via Getrate. I should add that SBT New and Getrate doesn't only have to be used when creating brand new projects either. A run-of-the-mill Getrate template could also add scaffolding to an existing project. This is what I use personally to add scripted test cases to my plugins. Since template evaluation is additive rather than destructive, you simply use dynamic file and directory names. When you execute your template, you have new directories and packages full of your boilerplate. I'll be honest though, I'm blurring the lines here as I explain the collective journey, because once you get comfortable making SBT work for you, you're really leveraging it beyond its build tool moniker. For us, necessity and discipline grew innovation. A powerful build tool, perhaps the most powerful build tool, once understood and tamed, allowed us to sculpt and shape our software repositories into well-working systems that are easy for our teams to improve, deploy, and continuously maintain. We had no desire to let our build process or difficulties with that process dictate the structure and organization of our code repositories. At TapAdd, we believe and respect Conways Law. To succinctly restate what you see above, the organization of the software and the organization of the software team will be congruent. I believe that paraphrasing comes from Eric S. Raymond. Mastery of our build tool allows us to structure our projects to better align with our organization and our organization's product lines. We don't agree with the notion of having a monorepo or a monolith by consequence of having a complex build definition, or because we've chosen to use a more complex build tool. You shouldn't justify having these monorepos and monoliths, and I'm not picking on that specifically, but you shouldn't justify having that because your project has grown too complex and you can't untangle it. This is actually a pet peeve of mine, and I think it's something that misinforms a lot of casual users. These architectural and organizational choices should be deliberate. They shouldn't be side effects. Say if we want to compose our projects back into a monorepo or back into monoliths at TapAdd, which we may do in the future, so be it. But it's going to be our deliberate choice to do so. And I'm confident that I would reach for SBT if I was tasked with such an initiative. Our familiarity with SBT and our hand-rolled plugins has allowed us to form software repositories and projects that fit the mold of our organization and the mold of our product teams. Over time, we've moved away from continuously dumping source and features into a monolith, and we've avoided the temptation of creating large-scale horizontal shared repositories. In the past, we've seen these quickly morph into tragedy of the commons type of scenarios. Collections of usually very important and often used code are left abandoned with no real owner, and they begin to rot and degrade rather quickly. Instead, we espouse the virtue that our projects should be product or vertically oriented. These at TapAdd we call vertical monoliths. We believe that the source, tests, schema definitions, code used for deployment, a project's build definition, is part of the product itself. And we prefer if it is all co-located in the same repository. And if each phase of that product's build, test, release, and deploy lifecycle can be invoked via our build tool. In our case, it's SBT. Now, one of the features that we highly value in our systems is a push-button release and deployment process that has somewhat been standardized across all of our teams. The goal here is not to just maximize developer productivity, but to increase developer capability and developer mobility. As our organization grows, a developer or data scientist that knows how to build, test, release, and deploy one system, by virtue knows how to build, test, release, and deploy all systems. So if developer ever needs to switch teams, needs to put out a raging fire in their off hours, they should feel confident and empowered to perform all of the roles in our SDLC across all product lines. We strive to keep this lexicon, this vocabulary, as simple and as small as possible. So from SBT, you would invoke release, HDFS publish, marathon service start, Docker compose up. These commands will work largely and perform the same high-level task across all of our systems. Now, one can argue that all of the above is possible using any form of automation, or with any build tool for that matter. That's true. We at TapAdd chose SBT for it, and we are very happy with the results. So hopefully those of you in attendance take the time to revisit SBT as your build tool of choice for Scala development. I think you'll find the road ahead much less challenging and much more rewarding than any of your previous attempts. The community behind SBT is both thriving and inspiring, and we at TapAdd are happy to contribute back to it. While it hasn't always been roses, SBT has proven itself to be an invaluable addition to our toolbox, and one that we find to be more empowering than it is limiting. Now, I'll open the floor for any questions and comments. We have a couple minutes. Also, these are some choice resources that really helped me along in my journey for understanding SBT better. I've posted all of these as tweets available on my Twitter feed. So definitely, I would say that group in the middle there, excellent for anybody interested in learning more about SBT, the stuff that you're not going to learn from a quick perusal of its documentation, or just by Googling for that matter. Do you have any questions?
Thank you. As a developer, I want my build tool to be stable enough to actually write build script once and then forget about it and just use the tool. With SBT right now, we have difficulties when running SBT. We have it failing spectacularly when, for example, running the console, the Scala console or something like that. And we actually don't have a major release right now. So we have what's called technology previews, and we have infrastructure based on Getrate repositories, which sometimes also fails. So what I want to ask is, what makes you think SBT right now is actually stable enough to use it extensively and to learn it extensively?
SBT has been stable for quite some time. So if you're using the 0.13 versions as opposed to SBT 1.0, which I can't really speak to, I really would think that there might be some contextual problems. Now, if you do have issues during that process, definitely ask for help too on the Gitter channel. Ask for help on a mailing list. Again, there are people to help you out with this, but I don't think, because it could be difficult to understand SBT for the first time, that you should just give up. I think there are plenty of people. Almost every single open source Scala project uses SBT as its build tool. So the fact that it doesn't work for your cases in particular could be specific to your context and the way that you're setting up your project. So I would just definitely ask for some help there. But I believe it's stable.
Thank you.
Hi. Thanks for the talk. I'm here.
Okay.
Hi. So you showed that you had some Getrate templates for your company, private ones. How do you do that? Is it possible to protect private templates, like store them somewhere in your private repository and invoke those, not something from the public?
Absolutely. So can you have private Getrate templates, basically, is the question. And yes, so every time you were to look at Getrate documentation or some tutorials, they're pretty much going to resolve the template by using a GitHub organization name and then a GitHub repository. But they don't really go into how you can execute this against a private GitHub repository. Simply, you use the full Git URL. So the same thing that you would use to check out a repository, you use that full URL. Secondly, you can also execute against local files. And this is what I mentioned, that I use Getrate for adding additional scripted tests to my plugins. What I'll do is I will keep Getrate templates inside my plugins repository, and then I'll just invoke SBT new with file : / the local path to that Getrate template. So Getrate can be used against private repositories. It can also be used against local resources, in addition to the nice GitHub organization, project name, syntax for public resolution.
Hello. I have a very simple but funny question for you, maybe. Why SBT is not using semantic versioning? Because it's not hard to follow what its measure changes and something like a 0, 15, 15 version. It's not easy to follow the changes, actually. Why is that?
So why does SBT not use semantic versioning? I can't answer that question, but I think Jorge might be able to answer it for you.
So I think Eugene is not here. He would be probably the best person to answer this question. So there's this convention in the Scala community to not stick to semantic versioning, but have another encoding of the versions in which, well, basically, so the problem with SBT versions is that they are more restrictive than semantic versioning. And that means that for us, minor versions are stable versions, and the patch part of the semantic versioning is the minor version, the minor qualifier in semantic versioning, right? So I don't know exactly the reason why the decision that was made by Maven to release SBT, but what I know is that you don't need to be afraid of using SBT versions in the sense that everything under O.x is stable right now, and we are right now working on SBT 1.0, in which we're doing like lots of changes in the API. So that's going to be, I think we're going to try to follow or stick to semantic versioning in the next versions.
So do you have any recommendations for a SBT project that contains 20 to 50 submodules and is quite big in general?
20 to 50 so any recommendations for a SBT project that includes 20 to 50 submodules? That is larger than I have previously worked with. I think the most I've worked with is probably 7 or 8 or so. Now, I believe there are some open source projects that do have quite a few submodules, but I personally, because I've never worked in that type of environment, can't give you any helpful recommendations or hints. Sorry about that, but I believe there might be some companies out there, if you just search on GitHub and see how many projects actually do this, or at least how many open source projects actually do this.
So I might have some recommendation for the large builds. So one of the interesting thing about subproject is that the dependency graph is independent for each subproject. So if you have 20 of them and each take, let's say, like 30 seconds, you have like 10 minutes of resolution. So one way to work around that is to try the cache resolution. So at least you have a graph resolution for a library, so your resolution time will be dramatically faster. And I think for open source lead chests, I think their resolution went from like 2 minutes down to like 4 seconds or 5 seconds or something like that. So initially you're going to get some hit, but definitely try the cache resolution for large builds.
All right, looks like that's about it. So thank you very much for attending.